Hello, welcome back to the channel, and today we're going to be learning the basics of how to make a simulator, and here are the skills that we're going to be covering today. Alright, first thing we need to do is create our script to store information on each of our players. So I'm going to add a script into server script service. If you don't know what this does, server script storage, it's just a storage place for server-side scripts. If you don't know, server-side scripts only work in server script service or workspace. So we're going to get the players and invoke player added. And this will give us an argument called player, which is the player that got added. And we're going to add a folder to every player that gets added. Okay, and I'm going to name this folder leader stats because there's a built-in function in Roblox where if you name a folder called leader stats and put it under a player, it can display information on the leaderboard or the player list. So I'm gonna play to make sure it's players. And now for information to actually display, you need to create int values. So what I've done here is when a player is added to the game, this player object spawns in, and as soon as it spawns in, it creates a folder named leader stats, and then I put in an int value, name it cash, and because of the built-in function, it will put cash into here and it will display it on the player list. Alright, what is an int value? An int value is an object you can add from typing an int value that allows you to store a number. And there are other types of values that do the same thing, storing different things or different like objects. So let's say we have a marketplace that's always increasing, and on another script we want to print out the market price. But we can't exactly call it on a variable that's stored on a different script. That's why we have this object, because on script A we can set this object's value to the actual market price, and on script B we can select the price from this value object, which is the int value called value, and then here we can share information about we can share information between scripts. So price.value. I need to put a comment, that's why it's red. If I play, it should print out market value after a few seconds. Alright, now is for the cash getting part, and for this video I'm going to be using these parts where you click on it and it will give you cash. The first thing to quickly set this up is obviously make the part, put it on the ground, anchor it, put a click detector, and then put a script. And what a click detector does is when it's parented to like a 3D part, you can select the click detector and invoke an event called mouse click, I think, yeah. And it will return the player object that clicked on it, the corresponding player object, which is useful because we're storing all of our information on the player object. So this is actually really convenient. So every time we click, it will click player dot leader stats, because that's where we're storing our cash. That cash will be increased by 1, but don't forget we have a multiplier and a base value, so we want to get the players multiplier, or no, base bonus first, and then group these together and then multiply it by the players multiplier. And before I test this, I should probably set these values to the multiplier to 1, so it doesn't multiply anything, and what's called the base bonus to 0, since most players will start off with 0. And after that, I'm going to print out the player's cash value after every click and output. That's if it works. So I spawned here, click, and error. Arithmetic out number, and oh yeah, I forgot. You gotta refer to the value of these things, because the object itself isn't the thing that has the value in it. It's the value property of that object. That's a common mistake. I make this mistake a lot, so now it works. Every time I click it, it adds 1. And let's say I increase my multiplier by 2 and our base bonus by 5. Now, what the math should do is, since my base bonus is 5, so the base value of this is 1 cash, so 1 plus 5 is 6, and I'm multiplying it by 2, so 6 becomes 12. And so every time I click this, I should get 12. So see, 120 plus 12 is 132. And for this one, obviously, I would just copy and paste these two things, put it into this one, and instead of having the base value of this object be 1, it will be 2. That means it will be 2 plus, my base bonus is 5, so it will be 7 multiplied by 2. That means it should give me 14 every click. And this one will give me 12. Alright, now it's time for the next step. So we're going to be using this door, the 100 cash door, and you're going to have to spend 100 cash to get rid of it. So first, we're going to get the part.touched event, and this will return the part that touched it. And what we're going to do is we're going to see if it's a humanoid and a player. So to see if it's a humanoid is we get a part.parent and then find first child that is named humanoid. Because if it was a player, it should have a humanoid object in it. However, NPCs can also be humanoid too. So that's why we select the players and then we use find first child on the parts parent. Because if it was actually a player, then the player model, which is in workspace, has the same name as your player object. And if that means an NPC cannot have a player object. So if we check if the player model or the character model's name is found in the player's like container object, that means that character is a player. Because this, and if I spawn in, okay, yeah, let me just show this real quick. This and this have the same name, 26Xander, which is my username. That's how and if I get the character model's name here, and see if it's here. That's how it works. Okay, and now I make the player object using the same method, because if it exists, it won't error. And now I check if the player's cache, which is inside leader stats, always remember that. Always remember to put value when you're trying to get the value, is above 100, then player.leaderStats.cache.value minus equal 100. And the door script.parent.canCollide equal false, and script.parent.transparency equal 1, which will make it invisible, and script.parent.billboard GUI. Oh, it's called script.parent.surface GUI.enabled equal false. That's what I use to put this text here. That means if I have over 100 cash and I touch it. So right now I can't get through, but if I get 100 cash, it disappears. And that's how you make a door. Now it's time for the save system. Alright, next step is we gotta save all of the information that we want to save. And so obviously I'm gonna save cash, base bonus, and multiplier, because those are important stuff, right? And of course, for the door, I'll also save that too if you bought the door before. So the first thing you want to start off with is get the data store service, because this is the start of all the saving stuff. So you gotta get game.getService, data stores. Yeah, data store service. And one more thing is, I'm gonna show it in a pop-up somewhere like here, I guess. You have to activate a setting that allows you to store stuff first, and this is completely safe. Every game uses it. How else are they gonna save? So once you've done that, now that I've gotten this data store service, I'm gonna get the data store, which is game.datastore service.getDataStore cache stats. And this, you have to remember the exact name. So if you're working with a lot of data stores, you want to like have a document that stores all the strings you use for data stores. We're not going to be using scope. We're not going to be using options. So in order to save, so when the player is added, it needs to load. But first we're going to make a save. So first we're going to do player.leave, or player removing, connect function player, and then with this I get the data store. But there's a problem that every person does. On the documentation, this thing doesn't have a 100% success rate. So what you want to do data stores is you gotta put local data and, or no, it was success and message. And then you gotta put a p call, and what a p call does is if this, it basically runs a function that you put in here, and if the function like causes an error, it won't end the script, and it will return these two things: the message being what would have appeared in the output if it was an error, and success is if true, that means nothing wrong happened; if false, something wrong happened. And if it does go right, then there won't be a message, but I just have it here just because. And now what I want my function to run is the actual saving part. So I get my data store, set async, which is the saving method, and the key is the player ID, or user ID, as user ID. So this cache stats data store stores everything cache stat related, and the key is, usually what people would do is put the player's user ID in the key. So and every user has a unique one, so we can save every individual player data under a data store. It's like storing a folder in a folder, basically. And the thing I want to save is the value which you put after. And conveniently enough, we can access our cache variables, our multiplier and base bonus variables, since we made an integer value that stores them already. So we're gonna get these as cache, which is in the player leader stats dot cache. The bonus And now that I got those, I'm gonna put them all inside the table and then save the table. Oh, yeah, God, you can't do that. Okay. So cache equal cache dot value, and then put a comma. Base bonus equal base bonus dot value. You get the gist. All saved onto a table, and then I save the table. And as I said earlier, this thing can go wrong, and to fix that, a way I found to fix that was I copy this entire function, I make a normal function called recursive load or recursive save. And if you know if you're already familiar with normal scripting terms or coding terms, you would probably know what I'm about to do. So I repaste the functionality, and if success equals nil or false, meaning it couldn't save, I just play the function again. And that should work. That should fix it. And I'm going to basically do the same thing with recursive load. So I copy and paste the same thing, name this recursive load. And loading is a little bit different. Instead of success and message, it returns success and the values loaded. So I don't need this table. All I need to do is get rid of all this. And instead of set async, I get async. Oops. And get async should get all the values. And since I'm returning values, and this is technically a function, I need to return this. And returning this will give me this value, because this is a function, and the return value of this function will be value. That means you don't actually need the value, but you wouldn't be getting anything from loading, so why would you ever do that? So once you do that, if successes fail, it will recursive load, and if it's true, let's say else, if it's true, then return value. After we got that part down, we're gonna get our variable called information, and using recursive load, it will return the value that it gets from loading it in and puts in this variable. So just to recap what everything happened, so first it will try to load the game and load anything stored on this key using this data store. Actually, and I'm gonna have like a diagram to show what happens. So first, let's say we save this table. It will be saved to this key under the data store cache stats, and if it couldn't save properly, it will play the function again to try to save it again. And once it's loaded, if something was saved to the player's user ID under the cache stats data store, it will be returned here. It will this method line will return a value that should be saved to the ID, which should be this table. And then it will return this value using this function, and like the other one, it will keep repeating the function until it loads properly. And since it returns a value, we have to of course assign a variable to the function to get our value back. And I forgot to put the function call right here so it actually saves. But if we test this out, if I got a bunch of cash here, it should save the fact that I have 96 cash. And if I play again, it saved the amount of cash I had from my last session. Now we have to move on to the saving if we have bought the door or not. And for the door, I just copy and pasted the recursive load script, except I changed certain stuff so it fits with the door script more, such as changing the data store to 100 cash store, because I'm saving a different item, but I'm still using the player ID key. So I'm saving on a different data store because on this data store, I'm saving a different item from a different script. It's just more convenient. It's also a lot easier to store it this way. I mean, you can technically make a data store for every new value. Like say, instead of just cash stats, it's just cash, and then I make a data store for the cash multiplier. But then I would have to save an individual value and have to recursive save for every single instance that I want to use a new data store. That's why I saved entire tables into a single data store key instead of making a new data store for every single item. The only exception to this is when I'm making it on a different script, because then it's easier to do. Now, I have recursive load here. It gets the value stored in the key under 100 cash store data store. And the save, I'm only saving a true or false value, a boolean, because the only thing I need to know from the script is if I have bought the door or not. And I'm only saving one thing that I need to know. So if the player owns the door, which will be returned by recursive load, when the player touches it, it will load the key stored under 100 cash store. And if the player does own it already, it will open the door. However, wait, I was getting ahead of myself. So this here will check, it will call on recursive load. If they own it, it will open the door. If else, then it will check if the player has enough cash to even buy the door. And once it checks if it has enough cash, it will save the fact that, oh, I forgot to put the, whoops, you call it. It will recursive save and save true to the player. That means they own the door, and then open the door after deducting 100 cash from their inventory. So if I play here, I have 120 cash. I bought the door. Oh, I don't know what happened there. But now that I own the door, if I replay, I still could open the door even though I had a negative cash. And let's say I would change the data store on the door so I can't open it anymore because it's saving on a different data store. I shouldn't be able to walk through the store because I don't have enough cash. But if I were to click here enough until I got enough again, I now have 100 cash. I bought the door. And if I leave and rejoin, I should have a negative cash because the script is draining all my cash whenever I touch the door for some reason. So I leave the game, I touch the door, and it opens, even though I have a negative cash. And just in case you're wondering, the reason I have negative cash is because the touch script, since I touch it and keep touching it, it technically counts as like 100 touches at once. So it deducted my cash 100 times. So you want to make like I forgot what you call it, but it's a boolean that prevents it from firing a touch script multiple times. So you just want to put that to fix that problem. So that's going to wrap up this video. Hope it was helpful. Yeah, basics to simulator. This is how you make a basic save system. Alright, bye bye.